In this demonstration, we're going to look at two utilities you can use to test name resolution with your DNS server system. The first utility is called nslookup, and the second utility is called dig. Before we go any further, I want to point out that nslookup is available on both Windows and Linux platforms. However, by default, dig is only available on the Linux platform. Before we do anything with these utilities, I want to check the IP configuration of my Windows workstation to make sure that it got the correct DNS server address when it received its IP addressing configuration from the DHCP server. To do that, at the command prompt, I'm going to type ipconfig/all. If we scroll up here, we should see that the DNS server address is set to 192.168.0.2. That's what we want, so it's working correctly. If we want to test whether or not our DNS server is able to resolve host names properly, we can enter nslookup at the command prompt. You actually have two different modes that you can run nslookup in. First, there's passive mode. You simply provide the host name you want resolved, such as nslookup corpnet.xyz. In this case, nslookup will send the query to the DNS server for the host name that you specify, return the response it gets from the DNS server, and exit out. That's one way to use nslookup. You can also use it in interactive mode, in which case you just enter nslookup at the prompt. Here you can enter as many host names as you'd like and have nslookup continually resolve them until you're done. When you're done, you can enter exit at the caret prompt to exit out of nslookup. Let's enter nslookup. After we do that, you'll notice I can see the host name and address of the DNS server that this workstation is going to use to resolve host names. The DNS server address is 192.168.0.2, and its host name is corpnet.dc1.corpnet.xyz. Let's use that DNS server to resolve corpnet.dc2.corpnet.xyz. I'll just spell out the fully qualified domain name and press enter. It sends that domain name to the DNS server, and it responds with the IP address that's been assigned to that host name. In this case, that's 192.168.0.3. In addition to resolving host names in zones that this DNS server is authoritative for, we can also look up names that it's not authoritative for. For example, I could enter the prompt testout.com. The response we get says non-authoritative answer. We didn't get that up here because the corpnet DC1 DNS server is authoritative for the corpnet.xyz zone, but it is not authoritative for the testout.com zone. Notice it was still able to resolve this DNS name into the IP address. How did it do that? It could because the DNS server is configured with root hints. These are IP addresses of root-level DNS servers on the internet that are pre-configured to send queries to domain names that they're not authoritative for. In this case, this DNS server was not authoritative for testout.com, so it sent that query to a root-level name server, which in turn pointed the corpnet DC1 DNS server to the DNS server that is authoritative for testout.com. My DNS server then sent the request to the DNS server that's authoritative for testout.com and asked it to resolve the host name. That remote server resolved the name and sent the response back to my DNS server, which returned it to my workstation through the nslookup command. We'll exit here. So that's how you use nslookup. Now we'll switch over to our Linux system. Let's look at a second utility called dig. Like I said earlier, the dig command isn't available by default on Windows systems, but it is available by default on Linux systems, and nslookup is available on both platforms. To use dig, I've switched over to an Ubuntu desktop Linux system, and we'll use it to send DNS name resolution queries to our corpnet DC1 name server. Just as I did with the Windows system, I want to make sure that my IP configuration is set properly. I'll use the ifconfig command at the command prompt of the Linux system. We can see that we're getting an address 192.168.0.100 from my DHCP server. Notice, however, that there is no DNS information there. The DNS information is stored in a file called resolve.conf on Linux systems. To view the contents of that file, I can enter cat/etc/resolve.conf at the command prompt, and my DNS information is viewable down here. I'll type clear to clear my screen. If I enter dig at the command prompt, it will, by default, use whatever name server is specified in the /etc/resolve.conf file. If, however, I wanted to use a different DNS server for some reason, I can still do that by entering an @ sign after the command followed by the IP address of the DNS server that I want to use. For example, on the remote subnet, I do have a DNS server that has an IP address of 192.168.1.10. If I wanted to use it instead of my Windows server, 192.168.0.2, I would put @ and then the IP address of that server on the same line. Then all my name resolution requests would go to that server instead of the default name server specified in the resolve.conf file. For now, I don't want to do that. I just want to use my 192.168.0.2 name server. I enter dig at the command prompt, followed by the type of lookup I want to perform. For example, I could enter A to do an A record lookup, followed by the DNS name that I want to look up. For example, corpnet dc2.corpnet.xyz. It'll perform an A record lookup on that host name. If, on the other hand, I want to perform a reverse lookup by looking up the pointer record, the PTR record, in the reverse zone, I enter dig PTR followed by the IP address of the host that I want to do the reverse lookup on. Instead of resolving the host name into the IP address, it'll resolve the IP address into the host name. I can also perform a CNAME lookup or alias lookup by entering dig CNAME at the command prompt, followed by the alias that I want to resolve into a host name. If I want to resolve a mail server record, I enter dig MX followed by the domain name of the mail server that I want to resolve. For our purposes today, let's just resolve an A record. I'll enter dig corpnet dc1.corpnet.xyz. Press enter. This sends the query to the name server. It responds with the corresponding record from the zone. Notice that compared to nslookup, dig displays a little more information. For example, down here we have the question section. In other words, this is the request for name resolution that I sent. I sent this domain name. I'm looking for an internet record, and I'm looking for an A record. In response, here's what I received. Corpnet dc1.corpnet.xyz resolves to 192.168.0.2. Down here, we see the query time, how long it took to make that resolution, in this case, 1 millisecond, and then the IP address for the server that was used to resolve the domain name into the IP address. Notice there's a number 53 over here. It specifies that the DNS server is listening on port 53, which is the default port used by DNS servers. Then the timestamp or the response, and then the size of the message. Let's clear our screen. Now let's do a non-authoritative lookup. We just do the same thing, dig. I'll point out here that if you don't specify a type of lookup to perform, by default, dig will perform an A record lookup. So in this case, I don't actually need to include the A here. I enter dig and let's do testout.com and hit enter. Just as with nslookup, the DNS server receives the response, recognizes that it is not authoritative for that zone, and goes out and queries a root level name server on the internet, which responds with the IP address of the DNS server that is authoritative for the testout.com zone. My DNS server then sends that name resolution request to the server that is authoritative for testout.com, receives the response, and then forwards the response down to the dig command on my Linux workstation. You can see here that we have the same information. Here's the question that was sent, testout.com. Just as before, we have our DNS server on port 53 and the timestamp. As I mentioned earlier, because we didn't specify a particular type of lookup to perform, by default, dig performed an A record lookup. Then we got our answer that told us testout.com resolves to the IP address of 67.192.129.239. That's it for this demonstration. In this demo, we talked about using nslookup and dig to perform both authoritative and non-authoritative DNS record lookups.